they all are Trimble employees, right? So, and Anmol has been a regular in my earlier workshop also, where he also did this text analytics, classification, clustering sessions, right? And I really I think Akash and all have introduced, right? So all these people, right? You keep repeating the same. I can't avoid it, right? It's a new person, right? They are quite strong in the Python front, right? But not just that, that algorithmic flair which these people will bring, right? That's the beauty about it, right? I think Anmol is quite strong on the mathematical modeling half, right? I think his BTech project was under my HOD, right, Saravapan, and who's also a fellow coordinator of the workshop, and he worked on something. It was joint variant with me and Saravapan on artistic neural network based style transfer, right? Let's see. I don't know if time we get tomorrow or sometime. 2, 3 projects at least. I want them to demonstrate it to you so that you see not their flair but Python's flair. Okay, right? So I think I'm sure Python, what Anmol and team and Santosh, right? They will make the session fruitful for you. Santosh, you can take over.
Okay, sir.
And whatever order you planned,
Yes, sir.
whether it's Anmol. No, I leave it to you. I just said you control it. That's it.
Yeah, Anmol, over to you.
Go ahead, right? My lunch is pending, right? So I'll finish. Anmol, take charge. Thank you. Yeah.
Yes, sir. Thank you, sir. Thank you, sir. Okay. Pardon. I'll just share my screen with everyone. Hope my screen is visible to everyone. In the ATAL workshop drive already shared with you guys, we have made some arrangement for resources that you can refer to while the session. There is one document for resources which contains all the important links and references that are there in the session, and you guys can check it out. And there's also one document for asking questions that you can use for asking questions for the session. Now, I would like you to, if possible, make the screen arrangement like this, where one window is of this much size and the other window is on the side, so that you can follow along during the session as it is a practice session. I'll give 5 minutes for making the setup so that it will be easy for everyone to follow along. Please feel free to ask any questions in the shared sheet or the chat in case anyone has any doubts.
Hello, sir.
Yes, ma'am.
Actually, my Jupyter is not getting configured. So can I work on the simple, ideally, the notepad also?
Ideal will not be will be difficult to use. I would suggest to use Colab. You can just 1 second. I'll tell. You can just go into the folder where we have shared the clustering notebook with you, and you can use open with Google Colab. Once it is opened in Google Colab.
Acha, so I have to install Google Colab?
No. I think this would have been covered in previous sessions. You just have to right click on the file and click open with Google Colab. The link for the resources I will share in the chat.
Yeah, I have the resources, sir. I just wanted to know about how to open it. Okay.
Anyone else? And once you have opened it, you can just click on file and save a copy in Drive, which will create a copy in Drive, and you can use that for editing during the session. Just click on open tab and you can code along with me during the session.
Okay, sir.
Okay. I'll just give 2 minutes for people to set things up. It will be making it easier for them to follow along, and understanding also will be better.
Anmol.
Yes, sir.
Yes, sir. Sorry for interrupting. Just 2-3 minutes. Okay.
Yes, sir. Sure, sir.
In fact, in the morning session, right, I have got your K-means, right, and the hierarchical, they are, okay, right? Uh, Hello.
Yes, sir.
Okay, so K-means and hierarchical clustering, right? They are aware of the working, but in the
Okay, sir.
Python demo, right?
Yes, sir.
Apart from these two packages, if you can, what a DB scan or any variety, if you think can be test driven and shown, you do that, right?
Sure, sir.
Algorithm basics, they can pick it up later. At least they can see the flair of the clustering packages. Huh?
Yeah, sure, sir.
I leave the choice to you. I'm not forcing anything. K-means and
Yes, sir.
hierarchical, I'm sure you will do. If you feel some of the packages are there, right?
Yes, sir.
Like DB scan or that, I leave the choice to you.
Yeah, sure, sir.
Thank you, Santosh. Bye. Sorry for this.
No issues, sir.
Bye.
Okay, so I hope everyone has the Collab notebook open and set up so that they can follow along. If not, then also you can watch the session and you will be able to understand what is happening. First of all, we have shared a link for visualizing k-means. So this will make you understand k-means a bit better, and even you can play along with it to see what configuration options you get with the algorithm. So for example, for initial centroids, I will just choose and we'll use a Gaussian mixture model. So we get 3 clusters of data, as we can see. If I select 3 points as centroids, these are the initial centroids that I have defined. Now I can tell the algorithm to start. So I'll go, and as in the k-means, there are 2 steps. First, it will update the centroids. So now means assign clusters to all the data points. So now all the red data points are in one cluster, blue in one, and green in one. And then on update centroids, it will recalculate the centroid for the each individual cluster, and then you get the updated centroids. So now I am reassigning points and updating centroids, but we can see visually that the centroids are not updating since they have already been in the local optimal position that we have. We can also try it in a different way, and I can just choose and Gaussian mixture, and now I'll give 1 point here, 1 point here, 1 point here, and ask the algorithm to start. So initially these belong to green, this belong to blue, and these belong to red. And now I am updating the cluster centers again and again, but this time the red cluster is this complete cluster of which we can see visually it's made up of 2 cluster points, while the blue cluster and the green cluster is made it's like a half of one complete cluster. So k-means does not guarantee that it will exactly cluster the points as we see them, but it will try to get to an optimal solution with each iteration. Like it will improve on the clustering with each iteration. We can also see that if I choose a Gaussian mixture model, and we can see visually there are 3 clusters. But if I give more clusters and ask the algorithm to go, then it will slowly get to a different clustering configuration. So here we can see that the yellow and green cluster is just half of one cluster, while there is not a single point in the red cluster. So number of initial clusters also matter in k-means algorithm. Now I can show one more case where we use with DB scan ring. So these are not clusters as we can see very easily. These are more like, if we were to see by eyes, we will see this one as cluster, this one as another cluster, and this one as another cluster, and so on. But if I randomly assign points using this and use k-means, then it won't detect the lines as clusters, because the way k-means works is to focus on globular clusters instead of density based clusters. There's another algorithm for helping with such clustering. It's called DB scan, which we'll touch upon in the session. Okay, so you guys also can follow along and try using this. You can try different shapes and see like a smiley shape and different clustering points, and see how the algorithm is performing and how is it updating clusters itself. I'll give 2 minutes for trying the visual demo out. Okay, so I hope that everyone was able to try the visualization page. You can also try it again other time and get to know what is happening. Okay, now let us try to use the code clustering for ourselves and see how is it working. So we will be using the scikit-learn library from Python. It is a famous machine learning library which is heavily used, and it has a lot of features which makes it easy. Like I'll just go and show the site. So scikit-learn is like the go-to repository for starting machine learning with Python. It has a lot of packages for classification, regression, clustering, dimensional reduction, model selection, and pre-processing. And it's in the NumPy, SciPy, Matplotlib stack of doing data science with Python. I think you guys will have been introduced with this library before. One section I would like to point out will be the user guide section, where you can actually look at the various machine learning models that are there, and they give a very good description of what each does also. So it's a good resource to check out uh, simple things like naive Bayes, linear models, kernel regression, support vector machine, etc. Since we are focusing on clustering, we'll just open the clustering page. Here we can show that there are a lot of algorithms that's available for clustering, but we'll be focusing mainly on k-means, db-scan, and hierarchical clustering, which is also called agglomerative clustering. And this shows a comparison of all the different models that are there on different types of data sets and how they perform. So the thing with clustering is that the notion of a cluster is not something which is very precise, which is subjective based on the use case. And we can define clusters as different ways. K-means defines clustering as a centroid based model, and it is the most common model that we use. Apart from that, there is also hierarchical clustering, which bases on connectivity, which we'll see in our session. And then there is density-based clustering, which bases on density, how closely packed are points inside a cluster. So now let us start with the clustering session in Python. So this is just importing some libraries. Matplotlib for plotting. Seaborn is just for styling. We don't use Seaborn for plotting here, but it integrates well with Matplotlib and makes our graphs beautiful. And Matplotlib inline is for making the graphs inline inside the Jupyter notebook itself. So first we'll try and generate some data. We'll use the make blobs function to generate data in clustering. Make blobs is used to generate cluster data where there are clusters in the data naturally. Okay, we'll see what does it look like. So here we have configured some parameters. We want 4 clusters, so centers is 4. We want 300 samples. We have a random initializing seed of 0. Standard deviation of the points inside the cluster is 0.6, and number of features that we want inside the cluster are 2. So we can easily plot them in a 2D graph. So what we get from this is the X is the actual data points and Y is the labels of clusters. So since we asked for 4 clusters, we got 0, 1, 3 and 2, and these are the data points. Now we'll just use Matplotlib to plot the data points and see how the clusters look. So the cluster looks as follows. We can see visually that clearly there are 4 clusters, 1, 2, 3 and 4. Now we'll try applying k-means for the same thing. You guys can also try and run this and change the parameters and see what changes there are. For example, I can change it to 3 or 2 clusters and run it. And then we'll see that there are 2 clusters of data that we get. So we'll stick with 4 for now. Okay, so we have the 4 clusters. I'll give a minute for people to just try out with the different options. I hope everyone tried out the make blobs function and see how data can be generated for our testing purposes. Now we are going to apply k-means algorithms on the same. So first we import k-means from sklearn clustering algorithm. Then we tell that we want 4 clusters. Now this is a hyperparameter. This is something we would not know if we can't see the data set like this or if we are not generating the data. So in a general use case, we will not be knowing from prior that how many data points or clusters are there. It will be completely unlabeled and it may not be 2-dimensional. In this case, we have taken 2-dimensional for clarity of understanding, but it may not be 2-dimensional. And here n init is the number of times k-means is number of time k-means will be run to find the best solution. So k-means what sklearn does it does not run the algorithm just once. It runs it multiple times to see what is the best solution that it is getting. So let's try running this. So now we can see that the cluster centers that we get from, we fit the data to the model, and then the cluster centers that we get from this are the 4 cluster centers as this. And the labels for all of the 300 data points that we had generated is what is given by the k-means algorithm. So now we can also change the verbose output to 1 so that we can see that, okay, how k-means is running internally. This is provided by sklearn again. So start iteration, done sorting, end inner loop, done sorting. And so this just runs by once because we have specified it to do till only once the best clustering is found. Okay, now we'll plot the clusters that we get. So we plot the data with the labels that we got, and this will be used to color the labels based on the number of colors we have, and after which we show the centers also. So cluster centers, this is the x coordinate, this is the y coordinate, and how many and the color that we want to specify. This is the size of the dot. So we can get the cluster centers also from this. Now we'll try to calculate the accuracy score of the clusters. Now, since we know the clusters beforehand itself, we can compare it with the test data that we get. But now let's try and calculate the accuracy score based on, okay, sorry. Based on accuracy score function provided by sklearn. Turns out that even though we can see clusters very well and we can see the points are clustered properly, but the accuracy score comes out to be 0. This is surprising, but this is because the cluster labels that sklearn assigns to the clusters is different from the cluster labels that that we have in the test data. So this has a cluster label of 0, while this has a cluster label of 1 in the test data. But when a k-means runs, this will be assigned some label 3, and this is assigned some label 2. So now getting the accuracy score from this causes an issue. So we need to find the actual cluster labels that can be assigned to the data and compare it with the test labels that we had. This function will permute the labels, and what it will do is for each cluster, it will find the most common label that we have assigned from the test data, and this will update the cluster label for that cluster to that test label that we have. So it chooses the most common label among the data points in the cluster and updates the cluster label for them. So now we can run find permutation, and it will permute such that the cluster labels in the test data are aligned with the cluster labels in the trained data. Now we can print it and we can see that the cluster labels are this, but if we print the original labels, that is model.tables underscore, and we'll see that, okay, the order was different for each cluster. Now, based on the new labels, we'll find the accuracy score, and we can see that it comes because it was very easy for k-means to find the clusters and discern the clusters very easily. Now I'll give like 2 minutes so that you guys can also try the algorithms out and see if you can understand or if you have any doubts. Okay, so I think everyone was able to just try out what was this and understand how clustering is happening in sklearn. This is a very basic introduction to what is clustering, and one issue we saw that we have to find the permutation of labels, since the label data is different from the labels that we generate after k-means. So for that, a lot of times, like there are certain measures that are there for evaluation, such as adjusted rand index. These measures take care of the permutations so that even if we permute the labels, for example, these were the original labels and these are the labels that we are assigning, and we are getting a metric of 2.0.24. But now if I permute the labels, so I am changing 1 and 0 and changing from 2 to 3. So I'm permuting the labels and changing the actual values. Then also I'll get the same metric. So there are measures which will take care of that issues that we were facing. So that is one measure, adjusted rand index. There are other measures also like homogeneity, completeness, etc. There is one important metric that I would like you guys to know about. That is the silhouette coefficient. Now, the silhouette coefficient, it tries to measure the thing when we don't have ground truth labels. That is with the case as most clustering algorithms. Silhouette coefficient tries to measure again the clustering efficiency if the points belong to the same cluster and the distance, mean distance between a sample and all the points in the same class, and the mean distance between a sample and all the points in the nearest cluster. And this can be used to find out if the clustering is done well or not. So this is one other metric, and it does not require ground truth labels like we had in the case we discussed just now. Hope everyone understood it clearly. Now we'll see some issues with clustering. So now I'll just run the clustering algorithm and I have made some changes. So here I have set that n into to be 1. So number of times k-means is run to find the best result will be 1, and maximum iterations will also be 1. So in each time that k-means is run. So we can see that even if clusters are there, but it is not clustering properly. So like this is somewhat in clustering style, but the centroid is very far from the cluster center. This clusters completely differently. So what happens is that clustering again depends on number of clusters and how many times k-means is run, and it's not guaranteed that we'll get globally optimal result. So we run it many times. So this parameter called n init that sklearn provides is defaulted to 10. So it will itself run k-means 10 times and try to find out which are the best clusters. And we can even increase this value, and we can change that how many maximum iterations it can go for each cluster. So this is one caveat of the k-means algorithm. Next, we find a number of clusters that must be selected beforehand. So what happens is, again, we need to know how many clusters are supposed to be there beforehand, which is something we might not know usually. So for example, right now I have initialized the same dataset that we have, but with 6 clusters. So we can still see that there is some clustering going on, but is it the best, or can there be a better clustering possible? That is something that we can't tell based on the number of clusters we initialize. So we need some metric to tell when we don't have labels. So as we discussed silhouette metrics before, this silhouette analysis is the same thing. So what we do is that we find the mean distance from one cluster point to all the members that are inside cluster, and we find the mean distance to all the members that are in the nearest neighboring cluster. And then we take that value and divide it. So we will get a value which is between -1 to 1. And so now on the y-axis, we can plot the cluster labels, and on the x-axis, the silhouette coefficient for each cluster label. So now for all points belonging to the 0th cluster, the silhouette coefficient is about 0.6, which is less than 1. So we want it to go as near 1 to indicate that clustering is well. So we can see that in cases like this, like where the clustering is, the silhouette coefficient is around 0.4 for a cluster, it is not good for us. While in cases like this where Szilard coefficient is very far. So we can set a threshold on our own. So this means that the cluster forms are very well, and we run the same clustering on algorithm on just one data set. So here we can see that there are 4 clusters and we got almost 4 clusters properly. So this is one way to tell whether clustering is good or bad without knowing the test levels beforehand. Now let us proceed with k-means is limited to linear cluster boundaries. As I was telling that clustering models are based on different definitions of what a cluster is. So k-means takes in the definition of centroid based model. Now in case we have a different kind of data set, like for example this, I'll just plot it. So here we again use from sklearn datasets the make moon function, before which we had used the make blobs function, which gives us clusters. In this we use the make moons function. So this gives us like 2 halves curves, and now we can try the same clustering algorithm on this dataset. So, and we can see that it got 2 clusters, one is this and one is this, but it's not according to how we would cluster it. So here we need some different approach or intuition of what is a cluster. So here we have another algorithm which is called DB-scan, which can be visualized here. So this will give an example of how does DB-scan work. So let's just stick with the default parameters for now and run the algorithm. So we can see that it starts with some data points and tries to keep on increasing the cluster based on the neighboring points. So we have 2 parameters. One is epsilon, which tells that how far should be the nearest point to consider it in the inside the cluster, and how many points should be in my cluster to expand the cluster. So let's just let it run and see how does it cluster this. So if you remember in k-means, we were getting clusters like this, this, and this. Some big clusters which were not like how these clusters are coming. So DB-scan takes intensity and tries to cluster based on that. So here we can see that it did cluster, but even though if we would have put all this complete into one cluster, it clustered into 4 different points. This can be changed based on the parameters that we pass to DB-scan, which follows a different clustering model, which basically tries to expand the model like how we would expand like something like how ants follow in a trail, like that we can imagine. So now let's see how DB-scan performs. So we'll import DB-scan and start with the epsilon value of 0.3. So distance to define the neighbor of the points to belong to the same cluster, and we'll fit it to the model and plot it. So let's see how this result. So we can see that the result with k-means gave a different cluster, but the result with DB-scan gave a proper clustering as we were expecting. Another caveat of the k-means algorithm is that it is not good for large number of samples, because it has to go through all the samples to update the cluster centers, and it will go on doing it each iteration. It's very computative. So instead we can just take a subset of the samples and update the cluster centers, where there's another version of k-means called mini batch k-means that comes into play. You can read more about it here. Okay, I hope everyone understood what is k-means and what is like a brief introduction to DB-scan, and they can see where the k-means and DB-scan algorithm differ and what is like both cater to the clustering category of algorithm, but just by definition of model, how the algorithm can differ and can produce different results and can be used for in different use cases. Okay, let's take a practical example of clustering digits in using k-means. So now we are again going to use the reduced MNIST data set, which I think would have been discussed before also in prior sessions. And we load that data set, and first thing we check the shape. So we have 1797 samples and 97 samples, and each has a 64 features. The value 64 is because every sample is a image of 8 cross 8 pixels. Now let us plot the data set. So we are plotting the first 10, 20 images and seeing the corresponding values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we can observe some things that in this data set like 8 and 1, we can easily confuse this 8 to be a 1 or a 7. So this data set is not very easy to differentiate. We'll try, since we know priorly that we have 10 clusters, we'll apply k-means on this and see. So now we apply with 10 clusters and fit the digit data and find the shape. So cluster centers, we get 10 cluster centers of size 64, 64 each. Now, since these are images, we can plot the cluster centers directly and see how they look. So I think you guys will be expecting something that they'll be something special, since there are numbers and we already know it is 10 clusters and we are plotting them. So let's plot and see what they are. So we can see that easily that 0, 4, 3, 7 or 1, 2, 9, 8, 5, 6 and 7. So that would probably be 1 or 7. So somewhat like the numbers we had, they have clustered the centers to one number of the digit. Now one can recognize the numbers from this, with the exception of maybe 8. What is the accuracy of the clustering that we did now? We'll again use the original algorithm that we had written for permutation of cluster labels so that we can find what is the accuracy. Here again we can see that 0 is assigned label 5. 0 is again assigned label 5 in the data set. 2 is assigned label 3. 2 is assigned label 9. 7 is assigned label 6. 7 in the original test set is assigned label 6 in the k-means output. So now we'll relevel the data using the previous functions that we discussed, and we check the accuracy score. So we get a pretty good accuracy of about 80%, which is very nice. So now we can use, since we have clustered the data, we can use this for classification itself. So we have discovered grouping of 80% in the digits, and now we can try to plot a confusion matrix. So these are the true labels that were assigned, and these are the predictive labels. So we can see that one actual label was predicted to be 8 a lot of times, and similarly 8 was predicted to be 9, which is quite reasonable since we saw that original data set like 8 looked like 1. Okay, this is writing k-means from scratch. This is like our own implementation. It is not as robust as what sklearn provides. Hence, we suggest you to not reinvent the wheel and instead rely on sklearn algorithms because they are trusted, they have more options and optimizations, and we can rely on it very well. So, but I'll just run this. You can also go and see if you can understand and see and understand how we are doing it internally. So these are the clusters that we get. It's a very simple implementation of k-means algorithms. This is an exercise that you can try in your spare time about using the same thing that we discussed. Instead of MNIST, you can use the IGEST dataset and try clustering and see how you are getting, what accuracy you are getting. The solution is there for reference. I hope everyone is following till now whatever we have discussed. I'll give 1 minute and then we'll proceed with hierarchical clustering. Okay, so let us continue with hierarchical clustering. Hierarchical clustering is a different approach from k-means algorithm. In k-means, we were doing centroid-based clustering, and it is good for globular kind of clustering. But in hierarchical clustering, we base on connectivity, and we join individual, like the hierarchical clustering can be categorized as two parts, as agglomerative or divisive, where we consider all the data points as one cluster and keep on dividing based on some metric into smaller clusters, and we can stop wherever, like we know if we want 10 clusters, we are getting 10 clusters. And in case of agglomerative clustering, which we are going to discuss, we consider each data point as single cluster and then agglomerate all them together. So I just show a visual of what is agglomerative clustering. So I hope it is visible. So we choose the nearest two data points and combine it into one cluster. Then we again choose the nearest two data points, which are these two, and combine into one cluster. And we choose the next two nearest, which are these two. But here we are taking this cluster to be 1 point and this to be 1 point, we combine, and we keep on repeating this process to get the complete data set as one cluster. So as I explain the exercise, it will be more clearer to you. This is the same thing where we combine two data points and get into one cluster. So let us use sklearn again to perform clustering. Here we'll take some sample data. So we create an array of points and then we use them to perform clustering. Let's just plot the above data. So after plotting, we get that these are the points, and we can see that, okay, if we were to divide it into two clusters, there are two very well-defined clusters. One thing about the agglomerative clustering is that there are two measures. First measure is the distance metric that we choose between the clusters. There can be many metrics such as Euclidean distance, Manhattan distance, cosine distance, etc. Different metrics are useful for different cases, such as for documents, we can use cosine metric. For usually the most common metric that we use is the Euclidean metric. Then we have another concept of linkage. Now what is linkage is that when we merge two data points into one cluster and we want the distance between cluster and a data point and cluster and another data point. So how do we consider that distance is what is linkage. So here this is a complete cluster. Now to get the distance between this cluster and this cluster, what we'll be doing is we'll take like single linkage means the nearest points of the cluster are considered. Complete linkage means the farthest points of the clusters are considered. So this metric also is used. So there are two parts to the agglomerative clustering. One is single, the linkage type, and the metric we use. So there are four metrics: single, complete, average, and word. Each has its own benefits and disadvantage. The single metric is better able to, since it uses the minimum distance between the cluster, is better able to cases where there are elliptical shapes or there is gap is too small. Uh, in case of complete linkage or average linkage, both will do well when there are globular clusters that we saw in K-means. Word is another metric which is similar to average, except it takes sum of squares of distance, and it also performs well for globular clusters and tries to minimize the variance in each cluster. So let us continue. So now we'll be using SciPy for this because sklearn does not give us any capability to graph clusters in case of agglomerated clustering. So we use SciPy to find the clusters. So we can specify the linkage as single. We can also specify complete and run the same. And we can find. So we can see that there are linkages that's defined in the package. So this is the standard that we use usually. There will be single, complete, average, and word linkages. And we can use any of this. Single, complete, average, weighted, centroid. So there are many. Now we plot and we get the dendrogram. Our dendrogram is nothing but on the y-axis we have distances between the clusters, and on the x-axis we have cluster points. So we can see that 2 and 3 were merged into one cluster at some distance around 8.5, and then it was merged again with the data point 1 at distance about 15, I say. So like that, this gives us the dendrogram. The dendrogram is useful to find which are clusters. Like if we can see that there's one cluster here and there is one cluster here, we can actually cut the dendrogram at a certain point and get the number of clusters we are desiring. Like if we cut here, we'll get 2 clusters. But if I cut on this line, then I'll get 1, 2, this complete thing as one cluster, this complete thing as one cluster, and this complete thing as one cluster. So there will be 4 clusters in that case. Next, we'll use hierarchical clustering using SciPy. So we can't plot it, but it gives hierarchical clustering. So we'll use that. Again, we can fit the model and predict the labels. So these are the labels that are predicted. So first 5 points are 1 and next 5 points are 0. Here we can specify the affinity as the distance metric. So it can be Euclidean, it can be Manhattan, it can be cosine, L1, etc. And linkage can be single, complete, word, and average. I would like you guys to try and see if you can understand. You can try out and see for yourself. Next, we'll print the cluster labels and we'll plot a graph of the same. So we have clusters with this and this. Now we do the same using a real data set. The data set has already been shared with you in the drive, wholesale customer data. You can download it and we can run the same thing on a real world data set and see how we are getting output. So you can save the data from here and you can upload it and you can try it along.
Anmol sir?
Yes, ma'am.
I'm getting error. I'm not able to run the code.
Could you share the screenshot in the question doc?
Yes, yes. Shall I share it?
Sure. What is the error you are getting?
It is showing that data is not connected, I think.
I think that is because we did you try uploading the data set
I
that I
shared
shared?
my screen, sir.
This one, wholesale customer data. So we won't be having the data set initially, but
Sir,
yeah,
yeah.
we have to download this wholesale customer data set either from here, and we can save that. And so I'll save this in desktop, and we
From
can.
sir, sorry, sir, your screen, if you can share it.
Yeah, my screen is. Oh, sorry.
Uh,
Sorry, I was not aware that it was not visible right now. Hope it is visible right now.
yes, yes.
Yes, so the dataset that we download, we can
Uh,
select that and upload it. So it just gives a warning that it will be deleted after we use it. So this is not our computer that we are working with. And once that is there, we can run and we can get the head of the data, first 5 rows of the data.
so data set from where you are downloaded, sir?
Data is already shared in the
Yeah,
drive.
yeah, wholesale customers, yeah.
Yes. This is from the UCI dataset repository. You can even download it from here. I hope you were able
Yes,
to
sir.
download the dataset. Excuse me, Vidya ma'am, can we proceed with the session?
Yes, sir. Sir, accuracy error it is still giving me. Accuracy score at the line accuracy score is.
Yeah, you have to remove the last 2 lines because they were there by mistake. So since accuracy score was there like this, so basically it should be like this right now. So it was
Accuracy
repeated
score is
and we
accuracy.
remove. Yeah, and then we can print it.
And permutation, sir? Permutation is equal to.
Pardon?
So permutation is equal to, there is one block of code wherein permutation is equal to find permutation it is written.
Yes. Yes, this one. So here we just need 2 lines, and this is what we need for accuracy score.
Print permutation.
Yes.
So 4 comma y. Find permutation is not defined, it is saying.
You have to run this block first.
Import scipy.
Yes, that one. Just run it once.
Yeah. New labels.
Is it working now, ma'am?
Yes, I am trying it, sir. So that 2 lines I have to remove, not some new labels.
Yes, yes. Last 2 lines.
And print accuracy score is.
Accuracy score is whatever you get. Accuracy score from Y, the labels that are in the test data and the labels that we get after permutation. I can share this snippet of code in the questions doc.
Showing Stack Overflow.
Ma'am, could you share a screenshot of that code snippet? Then I can better help.
Yeah. Shall I
We
check it in the chat box?
Yeah, we can check it out later. We can proceed. The other code should work without the need of that. So
Okay.
we can continue with the hierarchical clustering part.
Okay.
Thank you, ma'am. Okay, so as we were going through a real world dataset example, we just read the dataset and print the head, the first 5 rows of the dataset. After which we import the data frame and then normalize the data. Since we can see that the fresh and milk category have very large value, while there are channel and region which have very small value. This will bring all the values between 0 and 1 so that we won't have any discrepancy in the data and everything will be scaled uniformly. Next, we use the clean data set to plot the dendrograms for the same. So since there is a huge data set, it will take some time. And we can see that this is the dendrogram that we get. So we can observe 2 clusters and we can get as many clusters as we want by cutting at a certain location. Now we'll be plotting the same dendrogram, but what we'll be using will be cutting at location number 6. So we get 2 clusters after this. So now we give the same agglomerative clustering with number of clusters as 2, affinity as Euclidean, and the linkage as word. And we predict the date label. So these are the labels that's been predicted, after which we plot the results again. So we can observe one thing here is that if we plot with different columns, so we are plotting milk and grocery. Now we'll plot frozen and fresh. So here we can get 2 very nice clusters. But if we plot with different, here also the clusters are nice. But if we are plotting with different columns, then here we are not getting clusters that properly because the data that we have is 7-dimensional, and since there are so many dimensions, we have to cluster on which dimension that is not known. So here something called principal component analysis can be useful for determining we should cluster on these directions, and that will give us the best clusters. Okay, so that is what we had for clustering session. I hope it was informative and you got to understand what is K means, what is DB scan, what is agglomerative clustering, and then how we are doing it and how we can use it for clustering our data. As sir would have already mentioned that there are so many application of clustering, I think this will be very useful for everyone. Now we will proceed with the WhatsApp session. We'll just give 2 minutes, after which we will proceed with the WhatsApp chat analysis. So as sir had mentioned in the morning, to export the chat, were everyone of you able to export the chat and do you have the TXT file? I hope you have the chat file, or else I'll just give a demo of how we can do WhatsApp chat analysis. I have already the chat file exported following the steps shared in the resources doc. So we ignore media because if we put media, then it will be very large zip, and the way that WhatsApp media references are treated is also difficult. So I'll just show how does a chat file look like. So we can see that there's a date, then there is a time, and then there is a hyphen, and there is some message. So whenever, like in the chat that I have, there are 4 people: Nick Fury, Hulk, Captain America, Spider-Man, and Iron Man. So it's like you can see the name, you can see the message, you can see the time, and you can see the date. So um, yes. So now we'll continue with the same data that we have and see how can we perform analytics on the data that we got from WhatsApp. So we'll upload the data that we got. Once the data is uploaded, we'll rename it to chat.txt because that's how we have made it. Now, once we get obtained data from WhatsApp and we have uploaded data to Colab for working, now just some export imports, and we can see that chat.txt is there in the current working directory. So now we'll be reading the chat.txt line by line. So we'll open the file with encoding UTF-8. This is very important because WhatsApp data has emojis. So if we were to see the chat, we'll see that there are emojis in the chat data, and that needs the encoding to be UTF-8. And then we'll read every line and split the lines and get the content in a array called chat. So that is what we are doing here, and I will just print the array. So we can see that there's a big array with lots of messages that we got from the chat. Now we'll pretty print it instead because there's another library which can print it much better instead of the library we are using. So this way we can see that the messages are, and it's printed better than how the default Python's print function works. So we use a library called pretty print. Pprint. This is again provided by Python itself. So that prints it much better and we can read it. So let us proceed now. Now in WhatsApp, the usual conversations we have is single line messages. So like we can see that Spider-Man said something, that is one line. Then Nick Fury said something, that is another line. Everything is usually a single line. But if someone shares some links, then we have multi-line messages. So we, for our purposes, will be ignoring multi-line messages and only work with single line messages. So for that, we have to extract every line. Whenever there are multi-line messages, we'll see that they do not start with a date in the beginning. So again, here there's a link that someone shared, and that does not start with a date. So what we are doing is we are trying to parse this data. This is coming as a part of data exploration, data cleaning, and feature extractions from the data. So now if we can see that if we have a date and we parse it using the datetime function in Python, we need to import datetime. That because of that we are getting this error. Now it can parse properly and we get all the date. But if we parse something that is not a date with Python, then what happens is we'll get a value error. So this is a value error because it does not able to parse. So we can just use a simple for loop and extract date from the chat, and whenever we get a line which has a date, we'll append. We'll not do anything. But in case we are getting value error, we'll change that to NA, and then we'll remove all the NAs from the chat. So now we can get rid of all the multi-line messages which usually are links and not of our interest. So initially we had, okay, I have run this already. So it is 4914 again and again it's showing. But if I had not run this before, then initially I had around 5,000 messages. If we can see the ending file, then we can see there are 5,183 lines. but we have only 4,900 lines, which is after cleaning the multi-line messages. Now, if we focus on one message, then we can see that there is a date separated by a comma, then there is a hyphen, then there is a name that is separated by a colon. After that, there is a message. Now we'll try to parse this by using dot split function from Python. So what it does so if we have some text and we use split on comma, then it will split it on comma. So for example, if we have a string A, hello, comma, world, and we give a dot split, we'll get hello and world. And we can access individual items by saying hello world of 0, that is the first item, and hello world of 1, that is the second item. So now what we see is that for date, we can easily split at comma, and the rest will be time plus name, message, everything. And after that, for time, we can split at hyphen. So we split at comma and get the first part, which is the second part of the message, that is date, and we split at hyphen and get the first part, that is time. So for example, if we want to get the time from this message, first we'll split at comma, and then we get the first index. So 0 index will be the date, first index will be the time at the complete string, and after that we'll split again at hyphen and get the time part alone by asking for the first index on the first string that we split. So we'll perform that here, and similarly we do that for time and for name. And for message, we'll observe that there are some redundant messages that created by WhatsApp, such as Rahul created the group, Rahul at Gokul. So where we don't have this colon that we have. So we don't want such messages because these are just like admin messages and these do not represent the real text data that we have. So again, we'll employ the similar tick of an error where we'll try to split on a colon. So now when I try to split the string on a colon, what we observe is that it will split on time and it will split on the name. So and we try to get the index 2, which is index 0, index 1 and index 2. Since we are trying to get index 2, we will observe that in case of messages where Rahul created the group and added this, index 2 does not exist. Only we can split at the first index, this. So we will be getting an index error during that. So we'll use this function to parse data. Now we can see that like all libraries are not going to give us in a very formatted way like a CSV or a XLS file. So some cases we'll also have to parse data and we can do it very easily using Python. So in case of WhatsApp, we have seen that we can do this. Now we'll read everything into a data frame. And we can see that we get everything. So author Hulk has a laugh emoji, Captain America has welcome, Iron Man has lol, like that. So we can see all of it. Now let's explore data exploration where we just describe. So here we can see that Captain America is the most active member in the group and media omitted is the string that we are getting as the topmost string. This is why, because we chose to not include media. That's why we can see that this group has a lot of media that's shared and we chose not to include media. Now, now we'll try to use the data that we extracted to find the top 10 most active members in the group. So that we can do it by grouping the value by author and the number of messages per author. And that we can see that Captain America has the most messages at 1600, which passes Hulk by a lot. So he's a true leader, I think. Then we do the same thing with media. So we can see that even though Captain America is the one who is sending most messages, the most media is sent by Spider-Man instead of Captain America. So what we do for getting the media is, in the message section, we saw that we had values like media omitted because some messages will have media which we chose not to include. So now we can get those messages and then find the number of such messages per author. And using this, we can plot the first 10 on the um, graph and see who has the most number of uh, media messages in the group. So since we are just restricting ourselves to text messages, we'll remove the media messages from the messages that we have. So we had a media messages data frame which was containing just media messages. Now we drop those indexes from our data frame. This is the one which contains the data. So we remove all the messages which don't have media, and we get the head of the messages df. So index starts at 3. So 1 and 2 were media messages that are dropped. Now we'll see how to augment features from the data that we have. So we add letter count and word count from the messages that we have by using a simple function which counts the number of letters in the um, string, and one which counts the words by splitting the uh, string at a space and counting the number of letters. We can observe that we get two kinds of data here. One is continuous and one is non-continuous. So letter counts are a continuous value, while date, time, author, message are categorical values, since we have 5 unique authors. So we can employ different statistics when we use the describe function. But if we use on the complete data frame, we'll observe that it will give by default only continuous values and not discrete values in the describe method. So now we let us find out what are the most common number of words in a message. So we can find the word count of each message, and we can see that there's only most common is 1 by far. So let's wonder why there's 1 as the most common number of messages in number of words in a message. Maybe there's because WhatsApp data is structured in some way. Let's see. We can also find out what is the day the people were most active by grouping by date and plotting the number of messages in that day. So top 10. So we can find special days from such insights. Something special might have happened. And one interesting thing is like different groups will be active on different times. We can also find that by getting the hours from the time part and then showing the hours. So we can see that the group is very active during 9 and 10 in the midnight, but other days it is not that active. Now let us try, since WhatsApp data has emoji, to get the top 10 emojis for this. For this, we can see that we need an external library called emoji, which is not there. So we'll install that library. Once we have installed that library, we'll use this to create a list of emojis by which we split every message and check if each character is an emoji. If that character is an emoji, we'll append it to the list and we can show the top 10 from that. So we can see that the group is smiling and laughing for most of the emojis that are there. So we can conclude that like we got to see that okay, we can get some social media data like WhatsApp data and we can perform data analytics on it. So for social media analytics, we basically rely on the methods that we discussed previously, such as clustering, classification, NLP, all those, and then we can use this to do explorations on such data. A lot of time, the hard part is collecting data and cleaning data, which we saw that Python has a lot of features and we can use it for collecting data and cleaning and then using it to derive analytics from it. Here are some questions that you can explore later maybe and see if you can find those on your own. I hope you got some idea about how like we can obtain data from various sources and we can perform some analytics on it. You got to understand what is k-means, hierarchical clustering, DB scan, and why different algorithms have different models of clustering, and why it is difficult to predict the accuracy of clustering because we don't have labeled data beforehand. Instead, it's a very subjective process, as a lot of you might understand. And still, it is a very crucial part because it has a wide ranging applications, and also that it is the first step in data exploration, because naturally, like for example, if we are going to a new place, we'll see that okay, there are some clusters of people, like that there are some clusters of data, and then we can restrict our attention to some specific data that we need, or we can infer that okay, why are these data clustered in certain way. For example, we can segment customers in a business based on clustering to find okay, we can specific target specific products for each bracket of customers that we find. Similarly, we can use clustering to identify which are spam messages and which are not spam. So basically, we can make a classification model, and we can augment it with the clustering to get improved accuracy. And a lot of places this has been used, and it can give as much as 95% accuracy. I hope everyone understood what is clustering, what is social media analytics, and got to learn something from this session. If you have any questions, you can ask in the doc. And I hope it improved your understanding of what we have learned so far in the workshop, and maybe also help you recapitulate all the things that we learned, with like the power that Python gives us to perform so many things. Feel free to ask any questions, or if you have any questions, you can post in the doc. That's all for my side. Do check out the resources, that will definitely help in understanding also, and also there's lots of interesting things that you can find in the resources, especially the sklearn library itself. There are a lot of very useful guides there, and clustering, you can get huge details about what each algorithm does, and like what betterment we can do in each algorithm, and you can try it out on your own also. Thank you. That's all for my side for today.
Yeah, thank you, Anmol.
Thank you, sir.
In case if anyone have any doubts, you can ask him.
Yeah, or you can post it in the doc also.
Anmol, sorry to interrupt one small thing. Can you give a write access for the questions docs?
Sure. Sure.
Thanks.
Yeah, thank you, Akash.
Thank you, Akash.
Yeah, like as we like left with half an hour more, like we shall try with this morning's YouTube thing. Like in case if you feel like your bandwidth is somewhat low or something, they can wait for the others to like proceed with like getting the data, and then we'll be like sharing the data with you. That .csv file will be shared with you, so that from that point everyone can work on Gephi. It's fine, right, for everyone? So like I'll be like explaining you step by step again, so that simultaneously you can also try with this, and then we will upload the same CSV file into Gephi, and then we will find what are the betweenness centrality or other measures which are like important in degree, out degree, whatever is required. I guess my screen is visible to all. So as I've told you, you can open any browser and then you just give webscraper.io. Webscraper.io. Okay, I'll do in this way then. Like if I this size will be okay, right? Okay. Now, what you could do is you just right click and then you press on inspect. And then go for this web scraper. There'll be an option called web scraper. The only reason why I asked to open webscraper.io and then right click to have this inspect is, at times if you are opening directly in a normal web page, this web scraper might not be visible for some people, so that if you keep this webscraper.io, it will automatically come. Only for that reason, I'm asking you to go into webscraper.io and then inspect your page. If it is directly visible to you, there is no need of like entering into web scraper site or something. So now here you have something called create a new sitemap. So sitemap in the sense, here every video will be like a node, and then if one video is giving recommendation to another video, it will be like serving as a link. So we are going to create a map of all the videos being connected to each other, where links are the recommendations that comes from one video to another video. So just click on create sitemap. If you do that, you will be having a page like this in which it will ask for sitemap name and then a URL. So as I'm going to do it for a YouTube videos, I'm like opening any channel that you want. Let us suppose I have opened something. Okay, let's not. Okay, let's not get details into what channel I'm opening. Let us suppose I've opened something called Nationalist Hub. And then just go to videos. If you have enough bandwidth and all, you can try with CNN or Fox, anything of that news channels where there'll be like plenty of videos. So you just copy this URL and then you paste it here. This URL will tells about what are all the videos that were there in the channel on which you're going to extract data from. Like for example, these are all the videos that I have in this particular channel. Now, you just give any name for that. It is National Hub. Okay. NH. Okay. And one more thing, it will accept. It will. It will expect only lowercase. You should not be giving any other case. So I'm like giving it as National Hub demo or something. NH demo is the name I have given. And then I'm just clicking on create sitemap. So now sitemap will be created for you. And then what I'm going to do is, like I'm going to add a new selector. So name it, any name can be given for this. And here I'm like analyzing the video links here. So these are the links for that particular video. So it should be link. I hope everyone is like able to do this till this step. I can proceed, right? Further. Can I proceed, or should I wait for some more time? Okay. So I guess there were like no much problems. So just click on, see, you will be finding something called as a selector here. In selector, you just click on selector and then multiple videos, because you are like working with multiple videos. I'm selecting that multiple. So you just click on 1 or 2 videos so that every other video will be selected, as you have like selected for multiple here. And then you just click on done selecting. So you have created a root node for that, and then save it. So this is the root node. I mean, if I take a channel and if I want to get data from that, data here tells that what are all videos that are present in that particular channel. So that serves as a parent or root for me. So the recommendations which might come from other channels can be treated as a child. So I can, what I'll do is I'll be like opening any one video out of that. And then just click on this selector, because for every video, you are going to check for the recommendations further. So you have to go into that parent, and then you have to, I guess this is some promotion or something. Okay. Okay. Yeah. So here, this is the parent, and these are the links which were like given as a recommendation for that video. So just click on this so that you are entering into the parent node, and then you are like trying to get all the recommendations. So recommendations, I'll just take it as a child, or you can take it as source and target also, your wish. And then in the same way here, it can be link. It should be link here, and then go for select multiple. So I'm like clicking on these videos. So if you could see, everything in that page were like automatically being selected. Now I can directly click on this done selecting, and then I can save. So this is what the main steps which are required in order to have the main videos to be like taken into account, and then its recommendations. Now this is your sitemap that you have created, that is like NH demo. First, we will just check for your site graph. So from root, you have given a parent node, and then from parent node, you will having a child node. So these are the main videos in your channel. So this is the root of your channel. These are the videos which are present in the channel, and these are your recommendations. So now you can have screen. Like this is your page load delay and request interval. Request interval in the sense between like scraping into one video to another video, how much milliseconds should system pause for, and this page load delay can be adjusted depending upon your bandwidth. So I'm like not touching upon this. So I'll directly say start script. I hope everyone has completed this part. Okay, let this happen. Yeah, one more thing, like people who are not able to do this, we have already shared something called Fox CNN Data Wrangler.csv. So this comma separated file can be used for processing. Okay, so let's not waste time on that. Like everyone was able to see this Fox CNN data wrangler, right? You are able to access this file, right? Anmol, am I audible?
Yes, sir.
Yeah, okay. I just got doubt. Okay, fine. So what we will do is we will directly take that. I guess no, it's taking much time. Okay, let's not waste time. So I guess everyone would have installed this Jeffy inside your system. So once you open this, you go into file, and then you can open your spreadsheet, or you can directly say open, and then I'll send you Fox CNN Data Wrangler, right? So this one. So this is a Fox CNN Data Wrangler.csv file. So this is the file we have uploaded over there. So as I've told you, once your CSV file is downloaded, it will not be in this format. It will be in a very raw format, as it was shown in the morning. Not this. I'll check if it is over. Yeah, it is over. So this is what your data wrangler has scrapped for you. And then what I could do is, I'll just download it and I'll show you what will be the format. So this is how your data will be. So you will be having multiple columns in this way, wherein you will be having a root H referencer and a child referencer. So what we will be doing is, you will leave this root referencer and H referencer, and the other columns will be deleted. So if you delete it, you will be finding only a root referencer and a child referencer and a link between them. As we say that there'll be always a link between the videos that were like taken into account, and then, so this can be removed. Okay, this can also be removed. This can be removed. Okay, this is also removed. So I will make it as some source. And then this is this as target. And as there will be a link between these two, I will make a link as one for all the videos. So this is how you will be doing it, and you can save as .csv file. So once you have your Jeffy file, you are like, as I told, you can directly open that particular .csv file, and then you can press on next. So if you say finish, dear sir, kindly share the link for the files. Like, sir, it is already there in the shared ATAL DSP 2020 folder itself. Here you'll be finding Fox CNN Data Wrangler.csv. In the folder where we are like placing all the materials, you will be finding something called Fox CNN Data Wrangler.csv. After removing the other values, only the source and target and link were there. So you can directly use this data wrangler file. I thought in case if you have any power issues or network issues or lower bandwidth, you can directly use this .csv. So I can press on OK. And you will be finding a layout over here. So this is like Yifan who properties will be like will be giving you all the values which are required for you. So once it is plotted, and then if you say run, this is how your output will look like. Here you are finding something called as partition. So you can partition according to an attribute. This is your link. One second. Okay. So here for ranking, you can find your in degree and then out degree also. So if you apply in degree, so it will be like showing you what is the in degree for that. Second, this partition thing is not popping up correctly. Just a minute. Some issue with this. Okay. So in partition, you can select any of the attribute to check what will be the betweenness centrality. So these are the percentages of nodes with this particular degree centrality, with the 0, with 0.008 like that. So if you apply, it will be like automatically shown here. So, or you can check with this closeness centrality. You can even play with this degree. So how many nodes are with degree 1, 2, 67 and 332, or in degree, with in degree 0, in degree 1, in degree 2, and then other properties can also be seen, like out degree or even your page ranking also. So whatever you apply, it will be like shown over here. So this is how you can play with the different types of nodes and everything. Once you have a CSV file, just you need to do is you need to upload it, and then you can track down what are all the properties and all. I hope I'm clear. Mercy, PT sir has joined.
I'll check.
Anmol, is there anything that you want to share?
Sir, we can have. Hello.
Yeah, tell me.
We can have a demonstration of the Twitter API also. I have a demo for that.
Like,
If we have time.
I guess you will be hardly having some 10 minutes or so.
Okay.
If you want, you can just tell them, because even if they want to have like download data from Twitter and all, it needs n number of permissions, right?
Yeah. Twitter needs permission from Twitter side, which
Yeah.
can take from 2 to 3 days to 1 week, like
So
that.
if you have any data that is already downloaded, so what you could do is you could like show them and then explain how it will work and all.
Okay, sure. I'll give a short and quick demo of the Twitter API then.
Okay, okay. Yeah, over to you then.
Yeah, thank you, sir. I hope, is my screen visible?
Yeah, it is visible, Anmol.
Okay, thank you. Okay, so I'll just give a short introduction to how we can do analytics with Twitter's API. So first of all, for doing analytics with Twitter, we need to go to the site for developer.twitter.com and we need to sign in with our Twitter account first. Once we are signed in inside that Twitter account, we can go to our developer portal and here we can create apps. So we have apps section. So I have created an app for DSP demo. I can show the details. So I can not show keys and tokens because that will be generated only after approval from Twitter. But you can create an app and you have to give a name, demo, description, URL, all those. The key thing is that Twitter needs a valid reason for you to have an app, and once you have a valid reason, then only they'll give access to the API. And I'll just show how the key screen looks like. So this is the screen that will look like. There you will have API key. This is the key for interacting with an API, and for every app you will get access token. So you can give permissions for each app on a per app basis. So every app can have permissions to like read only and all those, and I can make it read write, or I can make read write and also allowing me to send direct messages. So this is how we get an app. Once we have an app, then we can use it for interacting with the Twitter API using a Python package called Tweepy. Tweepy gives us a very simple API to authenticate with Twitter, and then we can use for doing data analytics. So here, the most important things to notice are that we have a library called TextBlock. This is a library that's used for doing NLP related and text processing things. Word cloud is used to print word clouds, and we have Tweepy, which is used for getting tweets from Python. I'll just run this library quickly. So as I mentioned that we need some keys from Twitter to work with. So I'll just show a sample of the keys. So I have consumer secret, consumer key, access token, and access token secret. These four keys you need to specify to access the API. That I have already kept in a file called Twitter credentials new, and the sample was what I showed you. This is something you should not share with anyone else, because if they have these keys, then they can get access rights to publish tweets from your account, and which can cause privacy issues. So now we'll just get those put these keys and have it ready for our use. So now what we do is we get in the login credentials from the Twitter key file. This is just a JSON formatted file. That is how I have formatted it. And we get four values: the customer key, customer secret, access token, and access token secret. Using this, we use the Tweepy's OAuth handler to authenticate and get access to the Twitter API object. Once we get authentication, this API is the object we use for getting tweets out of Twitter. I hope everything is visible. Once we have that, you can go, it provides several methods for getting trends based on a location, which needs something called a where on earth ID, which is a Yahoo 30-bit to bit integer to define location. So India has a very specific where on earth ID. For worldwide trends, we use one as the where on earth ID. So that can give us trends. You can try this at when you have time. Since we are short on time, we'll give a quick demo of what is there. Then we have methods for searching Twitter object. So I can search data science tweets, which is top 10 most recent public tweets with the word data science and which are in English language. Similarly, I can search for machine learning tweets, uh, which are most popular. This is most recent because RPP is recent, while here it's more popular. Okay, so now we'll use this to extract top 100 tweets from Bill Gates' account, and we'll do some analytics on that. So here we get top 100 tweets from top 100 recent tweets from Bill Gates. So nearly 40 million people have Alzheimer's and dementia today. So if I go to Bill Gates Twitter, I'll be able to see the tweet itself. So nearly 40 million people have dementia today. Next is in our first podcast episode with Rashida Jones. So we can see the same in our first podcast episode. So this is how we interact with the Twitter API using Python. So TWP is the standard library in case if we want to collect data from Twitter using Python. Next, what tweets that we get, we can store it in an object. So this API returns data formatted in JSON, and it has a lot of fields such as full text, ID, created ad, source, favorite count, how many people have liked this, retweet count, how many people have retweeted it. And so it's like I will just print the first tweet from the post variable and then see load all the tweets into a data frame. So for the first tweet, we can see that we get so many details from Twitter. Now we can use this for our analytic purposes, and this is just basic. There's even more details that the Twitter API provides. After which we have to clean the links because it has a retweet, RT, and HTTPS in tweets a lot of places. So we will just clean this. We use regular expressions in Python to do this. So we substitute a string that matches retweet with an empty string or HTTPS with an empty string to remove that from every text message that we have, text tweet we have. Uh, Now we'll extract some sentiment features from this using text block. So text block gives us very easy methods for extracting sentiment. Basically, we can get text.sentiment.subjectivity, text.sentiment.polarity, and this subjectivity has a range from 0 to 1. So how subjective is the tweet, while the polarity, how polar, negative to positive. So negative is -1 to positive is +1. So we can see that we got subjectivity and polarity of all the tweets. So TWP means a text block makes it very easy to interact and quickly prototype some NLP functions if we want to. So there are other libraries, but TextBlob is one for quickly prototyping things with respect to NLP. Next, we'll try and visualize using a word cloud. So we join all the words and pass all the words to the word clouds in a list. So there we can see that the most recent tweets are COVID, world, health, pandemic, people, way. So he is a person who tries to solve problems and thinks about the problems at a big scale. So we can see that these are the most frequent words he talks and uses. And the bigger the word is, the more frequently it's been used. So world and COVID are the ones which is currently the highlight focus from the recent 100 tweets that we have collected. Next, we do an analysis of the tweets with gift, positive, negative, based on the polarity. So we simply, just based on the score that we have, we can tell whether it's positive, negative uh, for the tweet. So if it is negative, then it's negative. If it is positive, it is positive, like that. Once we have that, we can print positive tweets. So these are the top 10 positive to top 60, 100 positive tweets, and then we can plot the subjectivity and polarity on a scatter plot. So we can see that most of the tweets lie in the positively polar region, while very less are in the negative polar region. Now, if we plot this for different people, we can get different types of graphs. Now I skip to the main part where I'll just plot the overall sentiment, as in the graph of number of positive and negative and neutral. So Bill Gates as a person has a lot of positive tweets compared to negative tweets. But if we try for different people, we can observe different patterns, and then we can apply clustering to cluster these people. So this is one way to extract features, or basically sentimental features about people, and from Twitter data. So we learned that Tweety is a library in Python we use for working with Twitter, and how do we authenticate, what is the process of it, and how we can use the data that we get from Twitter to do some sentiment analysis or basic data analysis. Here are some things that you can use sentiment analysis about, such as audience segmentation, information discovery, like are there any more relevant topics, or what are the topics that are important, as we saw like COVID and world in the previous word cloud. For segmenting audience based on, like, we can get sentiment, and then we can see, okay, this is a in general positive person, this is a negative person, something like that. And we can use this social data for classifying people, classifying products, classifying how they react to different products, all that. Plethora of opportunities lies with the tremendous amount of data. As they say, it's the new oil. So it's definitely very useful right now to learn these techniques and have a knowledge about what they are, how can we use them. Hope this gave you a brief idea about how we can use the Twitter API. And that's all from my side for Twitter. Thank you.
Yeah, thank you so much, Anmol.
Thank you, sir.
Like for the previous session, like we will also have one more yoga session today also. 1 second.